Okay, today we're talking about two non-parametric tests that we're going to learn that have fewer and less stringent assumptions. These are more stringent tests, the t-tests. And so we know the t-tests are parametric statistics. So the assumptions to use those type of distribution-based tests are normality for sure. And then for the two-sample t-test, we have normality and then HOV. Now, there's some types of data that even after we try and transform it with our log transformation or any other transformation, we still can't meet that normality and or HOV. So we need some alternatives. So we turn to non-parametric. Those tests that don't rely on distribution, so they don't have that assumption of normality. So the first one we're going to learn is called the sign test. It's an alternative to the paired t-test. And it's similar to what we've done in the paired t-test where we have the before and after value and we minus those to look for the difference. But in this case, we lose the actual numeric value in the difference, and what we end up with is just the negative or positive sign associated with each difference. If there is no significant difference between groups, then there should be as many pluses or minuses occurring in the data set. We're going to compare that number of pluses or minuses to see if what we got occurred by chance or is low chance below our point. So the median difference between paired observations is 0 is our null hypothesis for the paired sign test. Excuse me. So why is it median now and not mean? Well, because now we're only talking about a distribution that we're testing for a probability of these. In this case, the one you see here, the distribution, the number of minuses. We're no longer looking at the actual values of those differences, so we don't get a mean of those. Okay. Now, there's no easy way to run a sign test in Minitab. And so actually what we're going to do is we'll have our data, we'll get the difference, we'll get the pluses and minuses. And to get a probability associated with, in this case, we're always going to, just as convenience in this class, we're always going to look for the probability for the number of minuses. Those are what we're going to consider successes, the number of minuses. Now, it would work out the same way if we did it with pluses, but let's just keep it simple and always look for the number of minuses. And so to get the probability for that number of minuses, we have to look at how many trials we have. And in this case, the trials is the number of observations for the paired data. So it's your sample size. And then we can use Excel or Minitab, and I prefer Minitab now versus Excel. And we'll say, okay, how many minuses did we get out of that number of sample size? And for every time we got a minus, what was the probability? So this is binomial, yes or no, plus or minus, kind of like a coin toss. So every time you got a minus, that single event's probability was 0.5. So we use that to get a cumulative probability to have that many minuses in that many trials. But this is always one-tailed from Minitab or Excel. So we have to multiply it by 2 in order to know if we're going to retain or reject our null. And again, our alpha is still going to be at 0.05. All right, the pros, not a lot of assumptions, just independence of observations and random sampling. Cons, we lose a lot of information. You can see we no longer have the magnitude of the change. All we have is these pluses or minuses. We lose power. Okay, we know that if we don't use the paired t-test, using this sign test has less power, so it would require larger sample sizes to even reject the null. And it's mathematically impossible to reject the null if you have less sample size less than 5. So if you can, use the paired t-test, but if not, now you have the sign test. The other non-parametric test that we're going to learn is the Mann Whitney U test. And it's an alternative to the two-sample t-test. And the other name for it is the Wilcoxon rank sum test. And so it is based on the ranks of the data. It actually is comparing the frequency distributions between the two groups, and it wants to, it's going to give an idea of the degree of shift of separation between two samples. The test statistic is called a U. That's what it is in your book. I will warn you that in Minitab, it's going to be W for Wilcoxon. So, but we'll stick with U here. We're still talking about median differences here for this when we do it. Again, we're not talking about normal data. And so we're talking about the median of one group equaling the median of the other group under the null. All right, the steps. You combine all the data observations from both groups in one column. So you stack them all up. You sort all those data values from smallest to largest. Now you still know what those data values and what group they came from, group 1 or group 2. So when you rank though, it doesn't matter the grouping. You're just ranking from smallest to largest, giving a value of 1 for the lowest value. Okay, if you get two data values that are exactly the same, and let's say you wanted to rank them both as 3, you give them the average rank. So those both would have 3.5, 3.5. All right, now you find the sum of the ranks for both groups. That's R, so that you can see that here in this R, okay? And that's just adding up the ranks for group 1 and group 2. You then calculate your test statistic. You'll start with U1. In the case, if you have one group with a smaller sample size, use that one for the U1 calculation, just a little bit easier. So you calculate U1, and then you calculate U2. Then you can go to the table. There is a Mann Whitney table, and you can find the critical value. Okay, and that critical value is based on the sample size in both groups. So if I had a sample size of 4 in one group and 6 in the other, my critical value would be 22. And this is a table where our alpha is set at 0.05. Now, if my U value, my U1 or U2, and I take the largest one of the two that I calculate from my data. If it's greater than the critical, you reject the null. If it's less than the critical, you retain the null. For larger samples, there is a normal approximation of U, it's called, and basically it's a Z transformation of our U statistic, our larger U value that we got from our data, and we can use that Z number to get a probability. And we can compare that also to a Z critical, which is always 1.96. Now in Minitab, you're going to see you're going to get that W, the U statistic, and that will always by default report the largest one, and it will give you a p-value, and it is actually based on this. So assumptions of sign tests and Mann Whitney, like I said, not many. Random sampling and independence of observations, but they don't assume normality or HOV in the case of a 2 sample. The only thing with Mann Whitney is it doesn't assume that the distribution, doesn't say it has to be a normal distribution, but it does assume that the distribution, the shape of it is similar in both groups.